This talk presents a work on the cost of privatization in transactional memory systems by Hagit Atiyah and Ishkari Lev. Transactional memory is inspired by classical database transactions. In this approach, concurrent processes synchronize via in-memory transactions. Transactions may have semantics. However, in many cases, they are defined by a sequence of read and write operations on a set of high-level data items. A transaction ends either by committing or by aborting. Committed transactions take effect at some single, unique point in time, while aborted transactions never become visible. Software implementation of transactional memory provides algorithms for operations applying primitives to base objects that represent transactions and data items. In practice, not all operations are read and write operations. Irrevocable operations such as I/O calls, allocation and deletions of objects cannot be executed within a transaction. In other cases, some operations are simply preferred to be executed outside the context of a transaction to improve performance. Therefore, application must access the same memory location from inside and outside a transaction. To indeed avoid transactional overhead, a core assumption in our work is that non-transactional accesses are uninstrumented and typically executed as a single load or a single store to the memory. Unsupervised combination of transactional and non-transactional operation may harm the system's consistency. Privatization-Safe STM hope to solve this problem. Privatization means to isolate some data, possibly by removing all references to the data, after which the process can privately access the data non-transactionally, without interference by other processes. Specifically, non-transactional reads get values written by earlier committed transaction, and privatized location is not written by any other thread. Implementation in which updates are deferred to after committing may violate both requirements, as a deferred update might write to a previously privatized location. A simple example is privatizing the nodes of a linked list by nullifying its head pointer. In addition to the privatizing transaction, consider other updating transaction writing to the blue items in the list. This example demonstrates that updating transaction cannot just write to the items. They must read first the head pointer to verify the items are not privatized. Some implementations use global lock and therefore easily support privatization. The updating transaction acquires the lock, and the privatizing transaction also acquires the lock for the duration of the transaction, or at least its commit phase. Obviously, this implementation are inherently sequential. In contrast, a progressive STM allows concurrent, non-conflicting transaction to proceed concurrently. Another option to efficiently support privatization is to track data conflicts. For example, the data structure manages update bookkeeping, where an update transaction either sets a flag or increments a counter while accessing the list. Many existing STMs, however, are oblivious. That is, a transaction cannot distinguish a non-conflicting transaction from a transaction with read-read conflict. Invisible reads means read operations do not write, therefore they are unobserved by other transactions. This seems to align well with the main objective of privatization to improve performance. However, our main results show that supporting privatization has a price that is linear in the number of privatized items. When reads are invisible, the lower bound refers to the size of dataset of the privatizing transaction. Basically, this means the privatizing transaction needs to access every item to be privatized. When reads are visible, there is a trade-off between the number of non-conflicting transactions that can proceed concurrently and the number of memory locations the transaction accesses. Therefore, in our linked list example, under the assumption of high parallelism and no exceptional bookkeeping, simply nullifying a single pointer won't work. To summarize, we show that unless the parallelism of the STM is reduced, or there is an option to track all conflict with other transactions, there is an inherent cost for privatization linear in the number of privatized items.